Hello friends, so today in this video we're actually going to discuss the 4 problems from the AtCoder beginner contest 183. It's a old problem set from AtCoder, but we're going to discuss the first 4 problems because the first 4 problems of AtCoder are relatively good. You will learn something new. Actually, from the C and D problems, you should solve all the C and D problems from all the AtCoder beginner contest, and E and F if you want to improve, but C and D is sufficiently good for you to go from a beginner to and somewhat intermediate levels. Okay, like in the starting of an intermediate level, if you just know the basics but you want to just improve your level, then you can just solve out both C and D of all the AtCoder beginner contest. Then you can somewhat try to see that your rating get improved, and then you can move down to E and F. Okay, but try to solve all the C and D problems. The first problem is very simple. It states that you are actually have to implement this ReLU function in which you actually give some integer x and you have to output according to this function. If x is greater than or equal to 0, then the answer is x itself, else if x is less than 0, then the answer is 0. So you can just take the input and just write down this condition, and then that's our answer. I don't have to show the code for this. The second problem is there is one edge case you have to think. The second problem is not too difficult too. It actually states that you are having a billiard ball at some coordinate which is given to you. Okay, so this is the xy axis, okay, and this is the x-axis, this is the y-axis. This is some billiard ball. You have to pass your billiard ball to some, like this is comma, like some capital X capital Y coordinate. You have to make your billiard ball go from this coordinate to this coordinate by hitting the x coordinate once. So you have to somehow first send your billiard ball to one coordinate, then hit your x coordinate, and then make your billiard ball go to this point. So can you tell that what is actually, so the problem is asking at what is the x component at which you actually have to hit the ball? Okay, from 0, what is the x coordinate? So in this case, as you can see, at 3 point like this, you can hit that, but as you can see, it can be in the double form. You just have to print out 10 to the -6 accuracy, precision. Now you can just draw this example, then you can make it very clear. So this is the ball. If you understand a law of reflection, the angle of incidence and the angle of reflection are same. Okay, so this is just the same thing. Whatever angle the ball will come is the same as angle of incidence and the reflection. So if this is theta, let's assume that, then this is also theta. So you know two angles. So as you can see, if this is the height which you know, this is the x comma y, small x small y, okay, and this is, let's assume, a comma b. Okay, so this is 0 comma 0. Okay, so you know, let's assume that you want to find out this distance now. Actually, at what position you have to hit, this is the x coordinate at which you have to hit your ball such that then it will go to this point. So instead of taking this, just take out this distance, this length, as x, because then we can add, because we know the x coordinate of this point, we can add this x because this is x, and then we can add that. So let's assume that I will mark it out as some another alpha. Okay, then x plus alpha is this actual distance. Okay, then this is alpha, and we know this a is actually a distance from this to this. Okay, this to this, we know that it is a. Okay, this we know that x, this is, we know alpha. So actually this length is a minus x minus alpha. This length we know it is y, this length we know it actually b. Then this is theta. So we just make the tan theta of both the triangles same, because as you can see, the theta is same. Okay, so we just make the y upon this length alpha is equal to b upon this value. Okay, and then we can find out x, and by finding out x, because we know all the other values, okay, sorry, we can find out alpha, and then alpha plus x is actually this distance. You can just write down the code for this, okay, and then it's not too difficult. The third problem is you are having n cities, and the time it takes from you to travel from city I to city J is Tij. Okay, so you are actually given a matrix in which if you travel from city 1 to 1, it's 0 obviously, 1 to 2, 1 to 3, 1 to 4, and then 2 to 1, and so on. So from I to J, what is the time it takes to travel between that city is given to you. Now what you actually have to find out is, now you can go around all the any path. Any path means that you can first go to city 1, then 2, then 3, then 5. Maybe you want to, so the problem statement actually asks you, among all those paths you can start from city 1. So you actually always have to start from city 1, visit all the other cities exactly once, okay, and then come back to city 1 again. among all those paths, because like they can multiple paths, you can go from 1 2 3 4 5 6 7 8, maybe there are 8 cities, 8 and then 1 again, or you can go to 1 then 3 2 and then 4 5 6 7 8 and then 1 again. So there can be multiple paths, but because if you go from one city to another, you have to find out what time it takes. So it actually asks you among all the paths, what are the paths in which the total time take is equal to k, exactly equal to k. So you just have to find out among all the paths what is exactly, like what are the paths, number of paths in which you will take exactly k, like k hours. Okay, if the time is in hours. Now because as you can see the n is small, which is like up to 8, you have to actually find out every permutation to go from 1, like from 1 go find out every permutation for all the rest numbers and just come back to 1 again. So what you can simply do in this problem is, because you have to go from 1, so 1 you'll keep aside. Among all the rest of the numbers, let's assume the number are 2 3 4 and 5, if there are 5 cities, then find out all the possible permutations of all of these numbers. So from 1, maybe one of the permutations is 2 3 4 5, and then when you come to the end of this permutation array, go to 1 again. You can find out like the possible time it takes for this particular answer. Then you can go to the next value, in which like you can take the permutation as the next permutation, maybe 2 3 5 4. Okay, and then you would do the same thing, go from this and come back again. You can find out the answer for every permutation, so you can use the next permutation function in next C++ and find out the value for every permutation, because in this you have to permute the different cities to find out the possible paths, because you have to iterate over all the possible cities, and then just go start from 1, go iterate over all the cities and then come to 1 again, and then find out the total time it takes, and then you just have to find out that whether that time is equal to k. If it is, then you just have to output, like just have to count out number of paths that have found that answer to be equal to k, and that's the answer. So I'll show you the code part now, because and all the codes will be in the description, you can check those code out also. So as you can see in this, so this is actually what I actually have is, yeah, this is solve function n and k. K is the like the value we want by the final answer, the total time for which you want to find out. N is total number of cities. Then make a distance, like what is the distance from I to the jth, because as you can see the values can be pretty large, 10 to the power 8. Okay, so just make a long to be on a safe side. So that's what I've made. Then take the input of all the distances. Then these are the different paths. So because my path means that what are different cities, because there are n cities, but we don't want to take 1, because as I've told you, if we don't have to take 1 in the permutation, because 1 is aside, we have to first start from 1 also only, and then just permute the rest of the cities. So that's why the total number of cities left is n minus 1. So that's what I've done. Make it like path for n minus 1 and just send all the cities from 1 2 3 4. So the first starting cities index is 0, then from 1. So that's what I've inserted, like cities from 1 2 3 4 till n. And then we just do a do while loop. Why I'm using do while loop? Because if we do a while loop for the first permutation, we will actually change the the first value, but the first case is also the particular case. What I mean by this is, when I first insert in the while loop, we just met with the first condition, let find out the next permutation, and because we are finding out the next permutation, we just ignore the initial first condition. The first condition is the array is like 2 3 4 5, like maybe there's 5 cities, 1 2 3 4 5. That condition is not met, because whenever I first go to the while condition, the next permutation function is called and we just go to the next permutation. And thus the better way is do a do while loop, such that we first check the first condition and then go to the next condition. Okay, or you can also like check the first condition by our own, which means that just write a for loop for finding out the like this particular, like the first path is valid or not. The first path is start from the first city, then go to all the cities in the ascending order, like 2 3 4 5, and then 5 to 1. Or you can like this do while loop. So in this do while loop, we just find out the value. Value means like what is the distance. So the first distance is going from the 0th to the path's 0th value. Path is a vector which stores all the cities. So path 0 is the starting city will go from 1. So 1 is actually the 0th city. Okay, so from 0th city will go to the first value. Then from the first path will go to the all the n cities. So this is the path from I to I plus 1 city. And then when you reach the I plus 1 city, like ith city, then you go to the first city, which is 0 city. So from this city you go again to the 0 city. And because now you have all the total time it takes to go in this value, and if this value is equal to k, then the answer is total, else the answer is no. And you just have to output how many cities or paths have the total values total. Okay. Then the fourth problem is water heater. it actually states that you have a water supply. In that water supply, what you're actually given is that water pipe actually supplies W liter of hot water per minute. So you have W, so you actually have W liters per minute. So if you can assume that you have some pipe, W liter is coming out every minute. Now there are N people who want to bath, and then every person requires PI liter of hot water per minute. Now every person's requirement is also given, and that person actually requires hot water from SI to TI. So they are actually giving you some time constraint that okay, from 2 p.m. to 5 p.m. that person actually requires hot water. And also the hot water cannot be stored, so you actually have to get the hot water from the pipe itself when the time it is there. So is it possible to meet all the constraints? When you are actually have given a time constraint like a sub array or like a time interval for which you actually have to supply the water, the first thing which comes to my mind is okay, I have to do some query type of thing, like I have to update this array so that okay, from this to this time I have some need. So what I mean by this is, let's assume that I will make a vector of time, okay, from 1 2 3 4 5 6 and so on. Maybe one person requires water from 1 hour to 3rd hour, and I require water of 3 liters per. So because as you can see, the problem is also I required PI liters of hot water per minute, so I also required in this manner only. So I required actually like 3 liter per minute. So it means that okay, per minute 3 liters is fixed for that person. Now another person may be required from 2nd hour to 3rd hour 5 liter per minute. Now the 4th person might require 4 hour to 5th hour 6 liter per minute. Okay, but maybe, so it means that at the particular time of 2 to 3 the total water requirement is 8. Now if the pipe is actually giving you 8 liters, then it is fine because both of the persons are requiring this amount of water and we cannot store the water. So we actually have to like find the condition in which I will supply 8 liters from the pipe. If 8 liters is not providing by the pipe, then the answer is no, because we cannot supply all the needs of the persons. So it means that we just have to ensure that we can make this array, this query, using like a point update. Okay, so if you know that we are somewhat doing a point update in which like if you want to update a value, so what I can do is I can make a empty array, okay, of different values. Let's assume that 1 2 3 4 5, and instead of updating, so let's assume that one person wants a water from 3 to 5 hour 3 liters, so I just have to update 3 3 3. The another person want water from 2 to 6 hour 2 liters, so I will update 2, then I will add 2 to it, 2 to it, 2 and 2. So in the end I will know that okay, at this point I will require 5 water, and at this point I will require 2 liters. So instead of doing this for every query, you can do this in which like if you want to update from A to L to R, it's a very simple like logic. If you know that if you want to update from L to R, just mark the Lth point as like if you want to what P water, so P at this L point, okay, and like minus P at this R point. Okay, and then you can, what you can do it is then you can update from like left to right and update all the values by 1. So or not, actually you can do this like addition. So it's like a standard like algorithm in which if you want to update some sections, okay, if you have n queries and you have to update these n sections, what you can do easily here is like find out the L and R, and then for the starting query point just add P to it, and from the ending query point add minus P to it, and then when you have updated all the queries, just move from left to right, make a sum variable and just add all the variables like value at each particular point, and that's the answer. Okay, and then you can find out that after filling out all the possible requirements, does every possible value is less than or equal to the pipe supply. The pipe supply is K. If it is less than equal to K, then the answer is okay, I can require or I can fulfill all the person need, else we cannot. And that's what we're gonna do. So the code is also very simple. The code will be in the description if you want to know the code. Okay, sorry. Yeah, so you can just do the same thing, just make a vector for that size, then take the input of starting, ending and P, just add P to the S, and for the ending part minus P, then do the total for all the values. And for any part of the total, if my total becomes greater than the supply, then the answer is no, because like we cannot supply that person, else the answer is yes, because we can supply all the person. I hope you understand the logic and the code for this problem, or like all the problems. If you still have not, you can mention on. Until next one, keep coding and bye.